Welcome, GCSE students, or whatever you're studying. Today we're delving into the captivating world of infrared radiation. So join me as we uncover its discovery, understand its nature, explore its uses, and highlight the potential risks which are associated with it. So let's start with the basics. In the early 19th century, a man named William Herschel made a remarkable discovery while experimenting with sunlight in a prism. So what he did is he took natural white light, which is a mixture of all the colors of the spectrum, the visible spectrum, and he shone it through his prism, which, because all of the different colors refract slightly differently, causes the white light to disperse into the various colors of the spectrum, right? So that's how you get that sort of rainbow effect. Now, what he did is he did an experiment involving temperature in those colors. He had a theory that the different colors that made up white light had different temperatures. So he started putting his thermometers down on each of the colors that he dispersed and recording their temperatures. And he had an inkling that there was potentially more colors, potentially more wavelengths hidden within the mixture of white light, which our eyes weren't able to detect. So what he did is he put a thermometer just beyond the red light, and he found that there was heat there as well. So he discovered there that there was an invisible form of radiation beyond the visible spectrum of light, which he termed calorific rays, which of later we now know as infrared radiation. Of course, infra meaning below, right? So below red, we have infrared, and that's what we know about, thanks to William Herschel. So what exactly is infrared radiation? Well, it's a type of electromagnetic radiation. Electromagnetic radiation simply being light. Now, there are certain parts of the electromagnetic spectrum, the range of electromagnetic waves that we can see and detect with our eyes. That would be the visible part. And then there are other ones which we can't detect with our eyes. Infrared is a longer wavelength than that of the visible light. These wavelengths can range from 700 nanometers to a millimeter, right? So although we can't see it with our eyes, many objects emit and absorb infrared radiation. So notice I said we can't detect it with our eyes. We can detect it with our skin because we can feel the heat content of infrared radiation. And we're also emitting ourselves infrared radiation. We are emitters ourselves, yeah? We are shining colors. We are shining infrared radiation. So we're kind of like a star in that aspect of we're shining out IR. And just because we can't see with our eyes doesn't mean it's not there. Now let's explore some practical uses of infrared radiation. One common application is thermal imaging. Thermal cameras detect infrared radiation by objects and convert it into a visible image that we can understand with our eyes. And this technology finds its uses in many fields, from firefighting to medical diagnosis. So we've got thermal engineering there for, and night vision comes into that category as well. We talked about the heat content of thermal radiation. It can be used for heating and cooking as well. So you might have an electric heater which is emitting infrared radiation, usually paired up with a fan to spread it out. It's also used for another everyday example is your TV remote control. It uses infrared radiation to communicate commands to the television. It's pretty cool. So short range communication like that, infrared radiation. I used to, on my Game Boy Color, had a little IR blaster on the front, and you could put the two infrared sensors next to each other and they could send information, and you got Pokemon mystery gifts and nonsense like that. Another use you might be familiar with is if, and this is actually a thing you can try out to mess around with infrared yourself. There is an IR blaster on the end of a Nintendo Wii remote. So there's an IR sensor. So what you can do is you can take that Wii remote, and instead of using the sensor bar connected to the television, you can simply use two candles, two heat sources, and you'll actually still be able to control your Nintendo Wii, because all that's doing is sensing the breaks in IR. So if you've got an IR set up in terms of just two lit candles, You can be using the Wii remote and it will detect the movement. Not as effectively as the IR blaster sensor bar that comes with it, but you can use two candles there. It's pretty wild. Maybe I'll show that sometime. However, it's essential to be aware of the potential risks that are associated with infrared radiation. While it's generally harmless in small doses, as we know, because we're exposed to IR constantly, prolonged exposure to high levels of infrared radiation can cause skin burns and it can cause eye damage as well because that's really sensitive. So to stay safe, you're always got to be using PPE. You've always got to be using protective gear when working with high intensity infrared sources, such as significant heat lamps or lasers. And remember never to stare directly into sources of infrared radiation, intense sources of infrared radiation, because although this is a non-ionizing part of the spectrum, yeah, it's not in the category of UV, X-rays, and gamma. There still is this risk that's associated with it if we're talking about high intensities. And there you have it, GCSE students or whoever you are. Hopefully, an illuminating journey through the discovery, nature, uses, and risks of infrared radiation. I hope you found this video both informative and hopefully engaging, as we talked about a few different things to do with IR. So until next time, keep exploring the fascinating world of science. I'm going to talk about more places you can find me next. So if you don't want to keep watching, that is fine. So again, thank you for your interest, your support. It means a lot. If you've got any questions or you need further assistance or you have any suggestions or requests, just let me know. This channel exists to promote and engage in the learning of primarily physics. Here's all my links, which are in the description as usual. The link tree to everything, the YouTube channel, you're already on it. I've got free and paid resources on the TES storefront. I've got a Twitter and Instagram. And if you're feeling especially generous, you can buy me a coffee so I can get, well, not a coffee, but so I can get new running shoes because I'm constantly buying new running shoes. Bye, bye, bye.